in this short YouTube, I'll show you how to do an independent t-test. And we'll start with some of these assumptions. So first of all, when you do an independent t-test, you're simply looking at whether the differences between two means, the mean in one group versus the mean in another group, are the same or whether they're different. And the assumptions are that you have a categorical variable and you look at these means for only two groups. You don't look at those mean values across more than two groups. And you also have a continuous variable that meets the conditions for normality. Another condition is that the variances for these two means are sufficiently similar. For example, the standard deviations for those two means are sufficiently similar. And then finally, that you have independent observations for each of the variables that you're using. So different participants in these two groups. The same person can't be in both groups, and one participant for observation in the continuous variables. So let's go into our data set for sex, temperature, and heart rate and do an independent t-test. So what we're doing is comparing means. So we go down to this option and we choose the independent t-test. We want to do this for body temperature and for heart rate. You can do it for more than one continuous variable at a time. The options here, we just choose the default. And then you have to select a grouping variable. And in this case, we want to look at this across men and women. So when they want you to define groups here, they just simply want you to enter the values for those two groups. So remember, males are 1, females are 2. So we simply enter a 1 for males, and we enter a 2 for females and continue. But imagine instead of sex, you had a variable for race. You could go in and say, I want to compare Hispanics to Asian, people who self-select to be Hispanic versus self-selecting being Asian. And you could look at differences in those means across those two groups. Even though your variable has more than one group, you would just have to select the number coded for Asians versus the number coded for Hispanics, and those would be your two groups. So now we are finished, and we have to stretch this out a bit so that we can see all of the results here. And so the first table just gives you the group statistics. So you can see for body temperature, they're pretty similar between males and females, but notice that standard deviation is also pretty, is different, but fairly similar, right? 0.7 if we round up and 0.7 if we round down, so they are quite similar. For heart rate, we have somewhat different, they're pretty close, but differences in heart rates. But notice that we have a bigger difference in those standard deviations. So one of those assumptions that we first look at, so if we look at our results, we really have two different tests that are done. On the left side of the table, we're looking at this, meeting this condition of having variances that are sufficiently similar. And we can see that we're meeting that condition for body temperature because it's not significant. But we're not meeting that condition for heart rate. So we have a problem here. We're not meeting that condition of having equal variances because they're so different. And we see that significance value at 0.04. So that simply means that when we go to the right side of the table to look at our results, that there is a significant difference in body temperature between males and females, and the p-value is less than 0.05. The p-value is right here. But we don't have a significant difference in heart rate between males and females, even though they are different. And part of the reason is that we have these larger variances. So if you have a larger standard deviation, it's a little harder to detect a difference. And what it means, and the reason that we have these two rows for each of these has to do with equal variances assumed, equal variances not assumed. So for body temperature, we would use these values for the results. And for heart rate, we would use the values in the bottom row. And we notice here that they're exactly the same, and sometimes that happens, but it's often the case for them to be somewhat different. So it just tells you what row you would use for reporting your results. And on this slide, in your PowerPoint, I've included some of this interpretive information that we've already talked about, and I also included an example of how you would report these results.